love this. Yeah. And the problem with this one is, yeah, I have to find something in the literature, an example from a reactions where just fortuitously the simplification arises. And so there aren't many of those where what you're about to see happens. And so, but then it's going to give it to us. So let's do 6 revisited. And I'm going to throw that pen away. 6 revisited. Calculate the molar solubility of silver chloride after having suffered through what we just went through, you're really going to understand what I mean by simplification of silver chloride in, what was the molarity?
0.3.
No. In 1 molar cyanide. Okay. Yeah. This is going to work nicely. And for, I give you the information. AgCl PKSP equals 9.74. And PKF for silver is it? Yep, there's 2 of them. PKF is equal to minus 18.74 by some happy coincidence.
0.74.
Yeah, by some happy coincidence, these are actually the numbers. It really does, and you'd be surprised what this is going to do for everything. It's all going to be so pretty. Okay, so we have reaction 1, silver chloride, solid, is in equilibrium with silver ions plus chloride ions. And reaction 2, I take the silver ions plus 2 cyanides in equilibrium with the silver dicyano-silver complex. Okay, and now I'm going to couple those 2 processes together. Silver drops out. I end up with reaction 3, and K1 equals 10 to the minus 9.74, K2 equals 10 to the 18.74. And 3, I got silver chloride, solid. Well, maybe I should write this one on the next board. I have silver for reaction 3, silver chloride, solid, plus 2 cyanides, aqueous, in equilibrium with the silver dicyano complex, plus, and that's aquated, plus the chloride ion aquated. And now reaction 3, is equal to 1 plus 2, right? Therefore, K3 is equal to what? K1 times K2 equals 10 to the minus 9.74 times 10 to the 18.74 equals 10 to the 9th.
Nice.
And these numbers are really just going to sort of really make life easy. So I'm going to hit the ice again. And I've got the initial concentration of this is 1.0 molar. I'll just say 1. This is 0. This is 0. What's this?
2x.
Minus 2x plus x and plus x. So 1 minus 2x, x, and x. Oh, I just love this after having experienced what we just went through. So now, I know that 10 to the 9th is equal to x squared over 1 minus 2x squared. Everybody knows why. Why? We're going to remind all the people viewing this. Why is that so? Why is it squared? It's the stoichiometric coefficient, so it fits in the mass action expression. The same reason we had the minus 2x in this term. Okay, and so that's equal to x over 1 minus 2x squared, and therefore 10 to the 9th, I take the square root, 10 to the 9th to the 1/2 power is equal to 10 to the 4.5 is equal to x over 1 minus 2x. So 10 to the 4.5 times 1 minus 2x equals x. And now I'm going to punch this through again, but this time I'm going to 10 to the 4.5 is equal to x times 1 minus, or 1 plus 2 times 10 to the 4.5. And then x is equal to 10 to the 4.5 over 1 plus 2 times 10 to the 4.5. Okay, now let's just look at these numbers for a second. 10 to the 4.5. What's that, roughly? Well, 0.5, so let's look at the mantissa. 0.5 is awfully close to, that's 0.477, which is 3. So this is around 3 times 10,000, so it's around 30,000. So what I'm trying to say here, 30,000 divided by, what's 2 times 30,000? 60,000? So 30,000 divided by 60,001. Awfully, in other words, what am I going to be able to neglect in the denominator?
The 1.
The 1. So this is not even almost equal to, it's really as close as we're ever going to get to 10 to the 4.5 divided by 2 times 10 to the 4.5 equals 1/5. Wasn't that nice?
That was easy.
Yeah. Oh, this makes life so much easier. And now, so that means that x, which is equal to the chloride concentration, is equal to 0.5 molar. Okay? And now, the ultimate question here is, what is the molar solubility? Well, now we're going to have to bring up the KSP for silver, for silver chloride. We have 10 to the minus 9.74 is equal to the silver ion concentration times the chloride ion concentration, and that's equal to the silver ion concentration times, well, let's just call this 1/2. Therefore, the silver ion concentration is equal to 2 times 10 to the minus 9.74, and that's that I would accept, molar. And we have now completed the problem. Wasn't that easier than that last abomination? Yes?
Could you raise up the...
I'm really sorry. You want me to raise up which board? You want to
No,
go?
yeah,
to
it's
the-
fine. I just wanted to see everything.
By all means. So everybody get that one?
Mhm.
There is going to be a problem on the test. And it's going to be a problem that will yield to a simplification like this.
That would be nice.
Oh, yeah, I can guarantee it. Because I'm going to write the test, yes.
So would you make that 10 to the 0.01 and then just add it?
We could, in other words, you mean
Let's
make this one a little different? Be like 10 to the minus 10th times the complement of the mantissa. We could, and then solve for the actual number. We could, but I would accept
No, he
this.
was saying, in place of the 2, just use,
0.5. What?
No, instead of 2, just put 10 to the 0.01.
10 to the point. Oh yeah. Oh wow. Let's do that. Yeah. Let's do. No, I like that. Let's go for it. And equals 10 to the 0.301 times 10 to the minus 9.74, and then I've got to go 1.74301, and that is a 9, this is a 3, and this is 439. Yeah, equals.
aren't you going to add them?
Well, no, this is positive, that's negative.
Oh, okay, I'm sorry.
And so, yeah, I did add them, but I just, this is on my scratch paper. That equals 10 to the minus 9.439, but wait, there's more. Now, how do I address that? Because if we want to carry it to the next extreme, we're going to take and bring the mantissa one further, or bring the characteristic to one further to the right, and then we deal with the mantissa here. The complement of the mantissa, which is 1.000439. This is 1. This is going to be in a 6. And this is 9 respect 4 is 5, 6, 1. So that would be equal to 10 to the 0.561 times 10 to the minus 10th. And now I've got pretty much a ballpark of it, because 477 is 3. 4 is going to be 0.602. So this is between 3 and 4. Okay, so that's going to be around 3.5 times 10 to the minus 10. Isn't that
That's the
nice?
solubility.
Molar or no molar?
Molar. Which